Hello, good morning everyone. Now, in previous lecture we have understand about the what is support, types of supports, types of loads and types of beams. In that case, we have also studied that how we can finding out the reactions at support on beam due to applied load. And we have understand about that how we can calculate reactions with the help of three equilibrium conditions. Now, today we are going to study about some different types of beams loaded with different types of loads. So, how we can calculate? For that, let's see. Here we have one simply supported beam. What they have told that determine the reactions at supports for the beam shown in the figure. Here we have simply supported beam having UDL, moment also there, point load also there, and having some distance. Hinge support at A, roller support at E. So, here due to this support, we have two reactions, one vertical and one horizontal, but here there is no horizontal load. So, here HA is equal to 0, so we can directly take vertical reaction only. So, we have conditions, and that condition sigma m0, sigma v0 and sigma h0. So, first of all, we have to convert this point load, this UDL in a point load. So, it is 5 into 3 and it is acting at a center of this 3 meter. Okay. So, let's start. Here taking moment at A, anti-clockwise moment is equal to clockwise moment. So, anti-clockwise moment is acting at A due to reaction at E. So, RE into 8 is equal to clockwise moment 5 into 3. So, it is UDL to point load multiply with 1.5 center of the 3 meter plus moment is directly calculated over here because it is a moment only, and 15 into 6. So, we will get the RE into 8 is equal to 117.5. So, RE is equal to 14.68 kilonewton, it is a upward. Now, second condition sigma V is equal to 0. So, sum of the vertical reaction is equal to vertical load. So, RA is equal to total vertical load minus RE. So, total vertical load is 5 into 3 plus 15. Here we can't calculate the moment because it is a force only. So, we have to neglect the moment over here. So, we will get RA is equal to 15.32 kilonewton. Another case, a beam is loaded as shown in the figure. Find the beam reactions. So, here whenever this kind of beam, what we have to? We have to take moment at support. Which support? Any one of them. So, anti-clockwise moment is equal to clockwise moment. So, our beam is something like this. It is a overhang beam. Here A, B and it is C. 2 kilonewton point load at A, 4 kilonewton point load at here and 2 kilonewton per meter moment over here. So, we have to convert this in the point load. Now, taking moment at B. So, anti-clockwise is equal to clockwise. So, anti-clockwise is equal to 2 into 1 and RC into 8 is equal to clockwise, means 4 into 2 plus 4, 2 into 4 into 6. So, we will get RC into 8 plus 2 is equal to 8 plus 48. So, we will get RC is equal to 6.75 kilonewton. Got it, everybody? Now, another condition, vertical force, summation of vertical force is equal to 0. So, RB plus RC is equal to 2 plus 4 plus 8. So, total load is equal to RB is equal to total load minus RC. So, here it is 7.25. 2 kilonewton load acting at A will produce anticlockwise moment, that we know. Now, find support reaction for a beam shown in the figure. It is also overhang beam, but it is a both side overhang beam. So, here UDL at left side overhang, 15 kilonewton point load at right side overhang, and 20 kilonewton is 4 meter from the support A. So, here again there is a no horizontal force, that is why RA is directly we can take that, and this is a roller, so it gives only a vertical reaction over there. Now, taking moment at A, anticlockwise is equal to clockwise. So, anticlockwise is equal to 8 into 3 into 1.5 plus RB into 7. So, it is something like this. And clockwise is equal to 20 into 4 plus 15 into 9. So, here RB into 7 plus 36 is equal to 80 plus 135. So, we will get RB is equal to 25.57 kilonewton upward. Here, and RA is equal to total load minus RB, that we know. So, total load is equal to 8 3s are 24 plus 20 plus 15 minus 25.57. So, RA is equal to 33.43 kilonewton. Okay, everybody? Good. Now, this is the most important case, and here we have UDL also there, point load also there, moment also there, and inclined force also there. Now, this is a simply supported beam having support at A and support at B. So, due to this inclined force, we will get two component of that. One is downward and another is towards the right. Now, we have all the distance over here. Due to this horizontal force, horizontal reaction is there. So, this support become a hinge support, and two reaction we will get vertical and horizontal, and here vertical reaction only is there. So, for that we have to again take moment at A. So, anticlockwise moment is equal to clockwise moment. So, here anticlockwise moment is equal to VB into 6 is equal to 12 into 2 into 1, it is a clockwise moment. 30 into 3, it is a clockwise moment. 30 kilonewton is directly moment. So, we will take directly summation of that 30 kilonewton, and the vertical force, that is 22.52 into 5. So, this all are the clockwise moment. So, we will get VB into 6 is equal to 256.6. So, VB is equal to 42.76 kilonewton. Clear? Now, horizontal and vertical conditions are there. So, we will get VA is equal to total vertical load minus VB. So, total vertical load, that is 24 plus 30 plus 22.52 minus this one. So, we will get VA is equal to 33.76 kilonewton. Now HA, HA is equal to 13 kilonewton directly. So here at A support we have two forces, horizontal and vertical. The horizontal force is HA is equal to 13 kilonewton and VA is equal to 33.76. So we will get resultant reaction of that. So RA is equal to under root of VA square plus HA square. So we will get RA is equal to 36.17 kilonewton. It is 36.17 kilonewton. Now we have to finding out the angle between them. So tan theta A is equal to VA upon HA. So we will get theta is equal to 68.94 over here. So this is our diagram of resultant reaction at support A due to two reaction horizontal and vertical are there. Clear? So whenever we have this kind of case, we have to finding out the resultant reaction of that. Now another most important case. Here we have support B is inclined support. So due to this inclination, we will get the inclined reaction because reaction is always perpendicular to the plane. So here RB is equal to incline, but whenever we are going to consideration of that equilibrium, then sigma H and sigma V both are 0. So we have to consider that RB in the vertical and in horizontal component. So here RB is equal to incline at 30 degree. So VB is equal to RB cos 30 and HB is equal to RB sin 30. So we have to take in consideration that two component of RB. And the another thing, this horizontal force is there, so HA also there and VA also there. So we have to take components of this 50 kilonewton 33.35 and here also 35.35. So these both are same because the angle is 45 degree. Now we have all the forces and reactions are in the form of vertical and horizontal. So first we have to take moment at A. Clockwise moment is equal to anti-clockwise moment. So anti-clockwise moment is equal to VB into 6. First VB and RB we have taking moment at A. VB into 6 is equal to 30 into 2 plus 35.35 into 4. So we will get VB is equal to 33.56. Now VA is equal to total load minus VB. So here we will get VA also. Now VB is equal to RB cos 30. So we will get RB is equal to 38.75. Once we will get RB, then we can also calculate HB. HB is equal to RB sin 30. So it is 19.37 is there. Now HA is equal to 35.35 minus HB. So we will get HA is equal to 35.98. It is a leftward. Now at support A, we have again two reaction HA and VA. So we have to take resultant reaction for that. So RA is equal to under root of VA square plus HA square. So that's why it is a 35.58 kilonewton incline, and the angle between resultant and horizontal, that is theta A is equal to tan inverse VA upon HA. So we will get 63.30 kilonewton. So whenever we have inclined support, we have to consideration that VB and HB in the form of sine and cos. Clear everybody? Now the again most important case, that is overhang beam with UDL, inclined point load, moment is there and UVL is there. So this UVL is very much important. So whenever we have this kind of situation, multiple loads are there, so we have to convert all that forces in the point load. So it is very much easier for us. So here first we have to take component of this 12 kilonewton force, vertical and horizontal. It is 12 sine 45 and here it is 12 cos 45. Now here there are simple support or hinge support. So we will get two reactions are there, VA and HA. Now this is a UDL and it is a moment, so it is very much simple for us. Now UVL is there. We can say that UVL is also triangle load. So the load is acting by its area. So load is acting is 1/2 into 10 into 3. So it is 15 kilonewton. But it is acting at 1/3 distance from the right angle triangle. So from here to here it is 1/3 of 3. So it is 1 kilonewton and here it is 2 kilonewton. Now what we have to do? Here we have to take moment at A. So anticlockwise moment is equal to clockwise moment. So anticlockwise is equal to 12 sine 45 into 1 and VB into 6. This 2 is anticlockwise moment and clockwise moment is equal to 10 into 6 into 3 plus 20 UDL plus 15 into 7. So we will get VB into 6 is equal to something 296.52. So VB is equal to 49.42 kilonewton upward. Now VA is equal to total load minus VB. So we will get VA is equal to 34.06. Now HA is equal to 12 cos 45. So we will get HA is equal to 8.48. Now we have VA and HA. So we have to calculate resultant reaction from that. So we will get resultant reaction, that is 35.10 kilonewton. Now angle between the tan theta A is equal to VA upon HA. So it is 34.06 upon 8.48. So we will get theta A is equal to 76 degree. Whenever we are going to calculate resultant reaction, then at that time we have to indicate of that reaction with the help of this figure. Now this is a cantilever beam and here it is cantilever beam loaded with UVL and point load also there. So we have to make two components from this 18 kilonewton force. So vertical component is equal to 18 sine 55. So it is 14.75 and horizontal, that is 10.32. Now we have to convert this UVL in the point load. So we will get some 1/2 into 5 into 3 and the distance from here to here 1/3 of 3. So it is a 1. So we know that fixed support gives us 3 reaction, vertical, horizontal and moment, that we have to calculate for the case. So sigma H is equal to HA, sigma H is equal to 0. That's why HA is equal to 18 cos 55. So it is 10.32. Sigma M is equal to 0. That's why MA is equal to 1/2 into 3 into 5 into 1/3 of 3 plus 18 sine 55 into 2. So we will get MA is equal to 36.96. Clear? And the vertical force, total summation of, that is VA. Another case, it is also overhang beam loaded with point load, UDL, UVL, moment, inclined force, all kind of forces are there. So here we will get VA and HA and here VB. Now we have to first convert these forces in the simplest form. So it is HAVA 10 kilonewton, 25 moment is there. Here it is 20 kilonewton, here it is a point load, and here it is vertical and horizontal components are there. So first of all we have to convert all the forces in the simplest form so that we can calculate easily moment for that. Now here taking moment at A, so anti-clockwise is equal to clockwise. So what we will get? VB into 8 plus 25 is equal to 10 into 2, it is a clockwise, 20 into 6, it is a clockwise, 15 into 11, sorry, 9 plus 20 sine 30, so 10 kilonewton into 11. So we will get VB from here, that is 45 kilonewton, and VA is equal to total vertical load minus VB. So 10, 20, 15 and 10 minus total vertical VB, that is 45. So we will get VA is equal to 10 kilonewton. Now sigma H is equal to 0. So at here horizontal force, that is 13.32. So we will get HA is equal to 13.32. Now we have to finding out the resultant reaction. We have HA, VA, so resultant reaction somewhere over here. So that's why RA is equal to under root of VA square plus HA square. So we will get RA is equal to 20 and theta A is equal to VA upon HA. So it is a 30 degree. Now we have to indicate like this. This is another case. Calculate the reaction of beam shown in the figure. So here first we have to calculate equivalent force couple system for this, and that we have understand in our previous chapters, that is coplanar non-concurrent forces. So component of these two is acting somewhere over here, 5 sin theta and 5 cos theta. Now these two force is acting on a D point, but due to this force we will get some moment 5 cos theta into 0.4 anticlockwise plus 5 sin 50 sin theta into 0.3. So we will get moment at D, and another things are remain same as previous example. So moment at D, that is 7 kilonewton into meter, that is anticlockwise. Now anticlockwise moment is equal to clockwise moment, so VB into 6 plus MD is equal to 20 into 1 plus 50 sin theta into 4.5. So we will get VB is equal to 24.66. Now VA is equal to vertical load minus VB. So we will get VA. Now HA 50 cos theta, so it is 40. So now we have VA and HA, so we have to calculate the resultant reaction for that and theta for that. Clear everybody? This is another case, same as, so convert this force into the moment, and two forces are there and the calculations are same. Simply supported beam, two moments are there, so clockwise moment and anti-clockwise moment, that we can calculate, and resultant reaction for the same. Clear? Now you have to calculate reaction once. After that you can calculate the shear force and bending moment. So in a next lecture we are going to understand about the what is shear force and what is bending moment and how we can calculate that shear force and bending moment. But before that we have to understand about this chapter. So first you have to go through these reactions. Till then I am going to take another chapter that is center of gravity. So tomorrow we will discuss on the center of gravity chapter. Okay, thank you very much.